Hi, and welcome to video 3 for section 1.1. This is the third of 4 videos for this section. In this section, we're going to look at some of the notation that we're going to be using throughout the semester, what certain things mean if we write it one way versus the other, how does that imply what numbers we're including, and then some terminology as well. So the first thing we want to look at here is what's known as set builder notation. So for example, if I have some set A and it's got the brace on the end here. So the brace means it's just whatever values are inside of what we're including. And when we're talking about a set, we mean like a set of numbers. It could mean very specific numbers. So in this case, if I have 1, 2, 3, 4, 5, 6, and because of these braces, it means just those numbers, not everything in between, not a combination of them, nothing like that, just these specific numbers. I can rewrite this saying that A is some value X with a vertical bar, and this vertical bar is shorthand for the terminology such that. So it means the set A is some value X such that, and then we just have to describe this. So, and this is where there's quite a bit of freedom. So you could say X is an integer, and X is greater than 0 and less than 7. So why do I pick 0 and 7 when I have 1 through 6? Well, because I'm saying it's not including those values. So maybe another way you write it is X is a counting number, and so we could all say X is a counting or a natural number. Sorry. So a counting number is a natural number. So that means a positive integer. And X is between 1 and 6. So these two things mean the same thing. It's a natural number, 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. And it's restricted, saying that X is greater than or equal to 1 and less than or equal to 6. 1, 2, 3, 4, 5, 6. So it's just a way, again, this set only had 6 numbers. But what if we're talking about all the numbers from 1 to 100? Well, you wouldn't want to have to write out 1 through 100 in an entire set. So you can use sort of this shorthand notation saying that X is an integer between 1 and 100, or a natural number between 1 and 100, instead of having to write out 0 to 100. So it's just the set builder notation. It's a way that we can describe sets of numbers without having to write every single one. Next, some terminology, union versus intersection. So think about, what does intersection mean in your daily life? Well, it's what? Intersection is the overlap, right? If you're driving your car on a road and you encounter an intersection, so the intersection is what? It is the overlap where these two roads meet. Intersection in math means the exact same thing. Where is there any overlap? Union means all. So if I'm talking about, let's say this is Maryland, and this is Trop. So the overlap of Maryland and Trop is just that little piece in the middle. the union of Maryland and Trop would be the entire road Maryland and the entire road of Trop. So if you said, what gas station is at the intersection of Maryland and Trop, you would just be looking at this point. If you said, what gas station is on the union of Maryland and Trop, you'd have to list all of them on Maryland and all of them on Trop. So, hopefully that helps a little bit, kind of relating it to a road. The intersection is just the overlap, the union is everything. Our notation for intersection so let's do notation for union first, because the notation for union is a big U. So the notation for intersection is an upside down U. So if you get confused, if it's on an exam and it's like, oh my gosh, is this the union or is this the intersection he's asking for? If it has two sets, if it's a U, it means it's the union. If it's an upside down U, it's the intersection. So let's look at an example. Let's say I have a set S that has the elements, and so elements are the individual numbers in there of 1, 2, 3, 4, 5. And I have another set T that has the elements 4, 5, 6, 7. And then a third set V, which has the elements 6, 7, and 8. So the first thing I want to know is what is S union T? So this means what? Union means all of it, everything from both sets, not just the overlap. So go ahead and try that if you want to pause, see if you can figure it out, then hit play again and check your answer. So if you did that, welcome back. So S union T means it's all the numbers that are in both S and T. So 1, 2, 3, 4, 5, 4, 5, 6, 7. So we have 1, 2, 3, 4, 5. And so if you're doing these kind of problems, it might be a good idea just to cross them out so you know you've accounted for them. Then I already have 4, I already have 5, so I'm just missing 6 and 7. So S union T would be 1, 2, 3, 4, 5, 6, 7. Number 2 is S intersect T. So this means what? It means the overlap. It means what numbers in each of these set is the same in both. So again, if you want to hit pause and come on back, if you did that, we're just going to be doing comparison. In S we have 1. There's no 1 in T. 2, no. 3, no. 4, yes. 5, yes. So we ran out of numbers in S, so it doesn't matter what else is left in T. We know that it's not part of the intersection, so the intersection of S and T would simply be 4 and 5. And lastly, how about S intersect V? So S is 1, no. 2, no. 3, no. 4, no. 5, no. Now I ran out of numbers. So there wasn't anything that there was an overlap. So the intersection, this case, we'd have an answer like this. A 0 with a diagonal line through it. And this is notation for the empty set. Meaning there is no overlap. There's nothing the same in either set. So that's the end of that example. Next, we're going to look at interval notation. And these are all on page 7 of the book. if you need to go back and reference it. So the first one, if I have something written like this, A comma B with parentheses on it, what this means, if I put it in set builder notation, this is all the values of x such that x is greater than A, less than B. So notice, it's not greater than or equal to, or less than or equal to, but it's because these parentheses means it's not included. This is what's known as an open set. So the ends, it doesn't actually have an end to the interval. It gets real close to A, but never really gets to A, and goes really close to B, but actually never gets to B. If we were to look at this on a number line, if I have some number A here and some number B, it's all the numbers between A and B, but A and B aren't included. And so the way we notate this is with an open circle. So all three of these things mean the same. Empty set here at A, so A is not included, B is not included because it's an open circle, but everything else in between is. And that's what this notation, A comma B with parentheses, means. I could also have what's known as a closed set, which now I get brackets on A and B. And this, in set builder notation, is the x such that x is greater than or equal to A, or less than or equal to B. So now the endpoints are included. So if I was to draw it on a number line, A to B, all the numbers between, and then I put a closed circle or a filled-in circle. Because in this case, these numbers are included. So by included, I mean A is included, B is included because of the bracket. You could have a combination of the two. So if I have parentheses A, comma, B, bracket, on a number line, this would mean what? It goes from A to B, all the numbers between. A is not included because of the parentheses, so that's an open circle. B is included because of the bracket, so a filled-in circle. And then a special case is when we're dealing with infinity. So a negative infinity to positive infinity. Always, when we're using interval notation with infinity, it's always going to be parentheses. Because negative infinity, positive infinity never really end. So we can't put a bracket on it because we couldn't fill in a circle. It just keeps going, right? And this means what? This is the set of all real numbers. And on a number line, it would be the whole thing would be shaded. So let's say we want to find intervals. And graph intersections and unions. So kind of some shortcuts here. Math people are lazy at times. You see all the different notation we use. So this is finding intervals and graphing intersections or unions. So let's say, first example, if I have the open interval 1 to 3 intersect the closed interval of 2 to 7. So the best way to do this, and if I was you guys, this is how I'd be doing it. draw the number lines, and then compare. We want intersections, so that means what? Where is there an overlap? So the first one, so let me just give myself a number line to start here. So the first one is what? From 1 to 3. It's open interval, so that means it gets an open circle at 1 and at 3, and it's everything in between. The second one is a closed interval from 2, no, that don't work, sorry. So a closed interval from 2 up to 7. So because it's closed, it's what? Filled in circle, and then everything in between. So then lastly, so that's these two intervals, but what I want, what it's asking me for is the intersection. So where is there the overlap? Well, it's from 2 up to 3. So I can start by doing that. I know it goes from 2 to 3, but here's the tricky part. Do I use a parenthesis? Do I use a bracket? Is it included? Is it not included? Intersection means what? It has to be included in both. So let's look at 2. Well, it's included in the blue because it's got a filled in circle, and obviously it's going through 2 here with the red line, so that one would be included. It gets a bracket. How about 3? Well, of course, the blue line's going through 3, so that's included. But here, 3 is not included because of the open circle. So since it's not included in the red, it can't be included in our answer, which means we need to put a parenthesis there. So that's our answer. The intersection of open set 1 to 3 with the closed set 2 to 7 is the mixed set from 2 to 3. 2 is included, 3 is not. Let's do another example here. You can try this. So how about open interval 1 to 3 union closed interval 2 to 7. So again, go ahead and try this. Hit pause, give it a shot, then hit play. We'll work it through, see if you get the same answer. All right, welcome back. Hopefully you got it. Well, we have the graph, so we can use the same graph here if we want. But the difference now is what? The difference is we're talking about union. So we're talking about everything if there's a line or a dot over it. So there's a line or a dot from everywhere from what? 1 to 7. So now we have to ask ourselves, is 1 or 7 included? Well, at 1, it's not, right? Because it's an open circle. So because it's an open circle here, it has to get the parenthesis in our answer. And 7, that endpoint is included. It's filled in circle. So because it's included, it gets a bracket. So for that union of 2 intervals, your answer should be the mixed set. 1 to 7, open parenthesis on the 1, or the parenthesis on the 1, bracket on the 7. And then last of this video, we're going to look at distance between points. On a real line. So we have the following. If A and B are real numbers, then the distance between them on a real line is given by the following. Distance, so this is our notation, distance from A to B is the absolute value of b minus a. So just a quick recall here, absolute value. If I have an absolute value of a positive number, it's just that number. If I have the absolute value of a negative number, it's just the positive of that value. So absolute value of -3 is +3. Absolute value is always going to give you a positive answer. And that makes sense for what this formula is, right? Like, I wouldn't say that the distance between Luxor and the Win is -3 miles. No, it's 3 miles. So depending which you're using as A or which you're using as B, if it was on a number line, ultimately the distance has to be a positive number. We don't have a negative distance unless if you start getting into like physics or something like that where the negative would imply direction. But in terms of the actual distance, that's a positive number. So we have to end up with a positive number if we have this kind of problem. So let's look at an example. Let's find the distance between -8 and 2. Which is my A, which is my B? Doesn't matter. That's why I'm taking absolute value. So let's do it both ways. The distance between these two is the absolute value of -8 minus, so it's, if I call this B and this A, so it's B, which is -8, minus A, which is 2. -8 minus 2 is -10. Absolute value of -10 is 10, meaning they're 10 units apart. Which makes sense, right? If we have this number line, here's 0, here's -8, here's 2, well there's 8 units here, and 2 units here, so a total of 10 units between them, 10. Let's say instead I said, okay, this is my A, and this is my B. So I have B, which is 2, minus A, so minus -8. And you're going to get sick and tired of hearing this from me, especially if you take my 127 class, if you take 181 and you watch my 181 videos. But I say it so much because it's the biggest area where people will lose points in math is when we start dealing with negatives. So if you have any negatives in a problem, if it's in a formula or if it's in a number given, slow down just a little bit. Everybody wants to rush through everything. Take a little bit extra time, make sure you pay attention to those negative signs. So the formula is what? B minus A. 2 minus -8, and that absolute value. So minus minus becomes plus. So it's 2 plus 8. 2 plus 8 is 10. Absolute value of 10 is 10. So same answer, no matter which order we did it, because of that absolute value feature. We're just talking about the distance between them. So that's the end of video 3. Sort of just some basic stuff. Again, our unions and intersections, definitions. The set notation, that's probably the most important part here because you'll be seeing that and you need to understand what it means if we have a parenthesis or a bracket. Come on back, we'll do video 4, which is just going to be some repeating decimal examples. I want to make sure you guys are comfortable with doing those kind of problems. So come on back and we'll see you in video 4.